Okay, what we're going to take a look at today are inverses of functions. So what we want to kind of view here are two functions. We have f of x as this function, and then g of x as this function, and you can see they kind of look pretty similar, right? So the first thing that we're going to do is I'm going to put them both into y1 and y2 so we can generate tables, and then I'm going to calculate f of 5. And then I'm going to calculate g of 11. Okay, so if I go over here to my tables, and I can see the 5 value is going to be 11 is going to be my output. And then if I go down to 11, you're going to see the output of 11 is actually 5. So this is kind of interesting here. So now if I calculate by hand, this time I'll do f of 0, and so I'll do 3 times 0 plus 7 divided by 2 is 7 over 2. And then if I do g of 7 over 2, let's use the store function in our calculator. All right, so if I go over to my calculator here, I'll use the store function. You can see I stored 7/2 in, and then I substitute that function in, and if I got g of 7/2, I'm getting the output of 0. So now we're going to look at f of g of -1. Okay, so let's just figure this out here. So first, g of -1. So if I go back to my table here, and I'm going to identify g of -1. So if I go up here, and then I got -1, and then notice my input here of -1, my output here is going to be -3. So now I'm looking at f of -3. So if I go over to here, I change my input to -3, look what I get out. I get out -1. So interesting here, what exactly is kind of happening here? If I do f of g of 5, let's check this one out, right? So if I try g of 5, let's go down to 5, and you're going to see my output is going to be 1. So I'm looking for f of 1. So now if I go over to 1 here, what is my output? I get 5. So that's interesting here. So without a calculator, determine the value of f of g of pi. Well, you're going to know now that f of g of pi is equal to pi. And the reason that that works like that is because they are inverses of each other. So this mapping notation is kind of really nice and unique here. And what we're looking at here is in exercise 1, you see that they're inverses of each other, right? The domain of f and then the range of f. And then here's the domain of g and then the range of g. So it kind of just makes like a circle that's going to go back and forth. If functions are inverses of each other, if I substitute something in here, you're going to get out that same exact value, okay? Now, on a simple level, right, inverses really kind of mean that we are switching the domain and range. So if I know that this point lies on y equals f of x, which of the points are going to be an f inverse of x? Okay, and you're going to see here, if x is -3 and y is 5, we're just going to switch those. And now we're going to get 5 is the x value, and then -3 is the y value. So let's take a look at how that works on a graph, because you can see here, what we're doing here is we have a linear function now. We've got f of x is this, right? And we're going to use the graph to answer the following questions. So what is f inverse of 2? All right, so I have the function here. So I say, well, what is f inverse of 2? So that's an interesting question. And what is the f inverse of -4? Okay, so what we're looking at here is where is the y value equal to 2? So if the output is 2, the input here is 6. And then if the output, that's taken from this point right here. So if the output is -4, what is the input? So we're thinking backwards with inverses. We would say -3, okay? So you want to determine the y-intercept of f inverse of x, and the y-intercept is where x is equal to 0, right? So if we're looking for the y-intercept, if we switch these around here, right, the point -2, 0 is an interesting point, and if I switch this around, we're going to get 0, 3. All right, so the y-intercept of the inverse function is going to be this point right here. So now let's take a look at what it looks like on the same set of axes. Let's graph it. All right, so all I'm going to do is switch the x and y points here. All right, so instead of 6, 2, what I'm going to do is 2, 1, 2, 3, 4, 5, 6. And instead of 3, 0, I'm going to put the point 0, 1, 2, 3. And instead of 0, -2, I'm going to choose -2, 0. And then switch this around, -3, -1. This is going to switch around to -4, -1, 2, 3. And you're going to see that point, 6, -6, is going to remain the same. So here, what we just drew here is the inverse of the function. Now, how do we know it's the inverse? We are just switching the domain and range. We are switching the x and y's. Okay? Now, you can do this algebraically by switching the x and y's and solving. So what I'm going to do, I'm going to write out the function. I'm going to say x equals 2/3 y minus 2. And now I'm just going to solve for y. So if I solve for y, I'm going to add 2 to both sides. So I will get x plus 2 equals 2/3 y. And then our last and final step, again, multiply by the inverse on both sides. So 3 over 3, 2 over 2. So now what I'm going to get here is this, 3/2 x. And then 3/2 times 2 is 3, is equal to y. So this is the equation of the inverse. And very clearly here, what works out nicely, you can see is there's the y-intercept. And you can see there's the y-intercept up there. Okay? So in short, just really quickly, what you need to know, if you want to find an inverse of a function, you're just going to switch the x and y. So instead of writing y equals 3/5 x plus 6, what I'm going to do is switch that around and say x equals 3/5 y plus 6. And then I just solve for y. So if I subtract 6 from both sides, I'm going to get x minus 6 is equals to 3/5 of y, and then isolate y by using the reciprocal here. 5 divided by 5 is 1, 3 divided by 3 is 1. So now I've got y all by itself. And when I multiply in here, you can see I'm just going to distribute, and I'm going to get the following. I'm going to get 5/3 x. And you can see when we simplify here, we would get 5/3 times 6 is minus 10. So you can say f inverse now of x is 5/3 x minus 10. And you can see that both of these functions are now inverses of each other. Okay? All right, good luck, y'all.